This is for Year 12 Further Maths. We're going to look at exercise 9E, question 2. Okay, so we're looking at time series plots, and we're doing graphing and finding the regression line and things like that. So the table shows the percentage of total retail sales that have been made in department stores over an 11-year period. Okay, so we've got not seasonal data, but we've got time series data that spans yearly. Okay, and we're looking at the sales for 11 years. Okay, construct a time series plot. Okay, so with time series, time is always the explanatory variable, and sales is always the response variable. Okay, so we should all know that, but just making sure. So we need to construct a time series plot. Now, they don't give us a graph, so we've got to draw our own. So I've sort of cheated and used some grid paper. Now, if I go smaller, now with a graph, you always have to make sure you choose the right scale. So let's make that decision right now. I've already done it, but I want to show you the decision-making process. Okay, so the year numbers are fine because it's just 1 to 11, and it's quite nice. It's going up by ones. But the sales is spanning from 9.4 to 12.3. Okay. Because it's spanning such a narrow range, you're not going to draw a scale that starts at 0 and go in ones, because that doesn't really make sense. So a better approach would be to start at 8 and then go by 0.2. So 8.2, 8.4, 8.6, 8.8, 9, 9.2, 9.4, 9.6, 9.8. So that works out well. Okay, so you can sort of cheat and start at a high number if you want to. Okay, you do not have to start at 0. The reason why I'm starting at a high number is because I want to show the graph a bit better. Now, also, you need to, with any scatter plot, you need to show your labels to the axis. So sales is RV and year numbers EV. Okay, if there's units, you put the units in. And I've basically plotted the time series on here. Now, I want to get full marks here because I didn't connect the dots. You always have to connect the dots. Now, I don't have a ruler, so it's not going to look as neat as your one, but you need to make sure you connect the dots for a time series. Okay? Don't just draw a scatter plot, because that's worth a mark if you get that. If you didn't draw the time series, the dots on the sack. Now, so we've done our scatter plots. Our next task is to time series plot. Sorry. Our next task is to comment. Oops. Our next task is to fit a trend line or comment on the time series plot. So we can see from the time series plot what's the general trend. It's going down, right? Okay, so the official term is decreasing trend. So there's a decreasing trend, overall decreasing. So we've done the trend, we commented on the time series plot. Now it says fit a regression line for the time series. Find the equation and interpret its slope. Okay, so I've entered the data on my CAS calculator. So if we go back to statistics, I've entered the year numbers, so 1 to 11, and I've entered the corresponding sales figures. So I'm going to go calc, regression, linear regression. List 1's my explanatory, and list 2's my response. Good. Okay. We don't really need residuals in this case, so just leave that. Click OK. And we can see we'll write the equation. So find this equation. We know that the response, so sales percentage is equal to free sig fix. So if you look at our A value, it's 12.467. So free sig fix, it's that significant. 2 point, so 12.5. We have to round up. So 12.5. 12.5 is free sig fix. Minus, so greater than negative, which makes sense. 0.258. Okay, 0.258 times our explanatory variable, which is year number. Okay, perfect. So, and then we're asked to interpret the slope. So always highlight the things you need to do in the question. So make sure you do it, because you don't want to miss marks by not doing it. So what does slope tell us? It's negative. Okay, remember the negative belongs to the gradient. Okay, so negative, we got negative 2.5258. Okay, so on average, and you always follow the script, on average, when you ask to interpret slope, on average, the sales percentage decreases by 0.258 for every every 1 year, or every year is fine. So on average, the sales percentage decreases by 0.5258 for every 1 year. Okay, for every 1 year increase. For every, actually that's not good grammar. For every increase in year number. So on average, the sales percentage decreased by 0.5258 for every increase in year number. Okay. So now it says draw a trend line to your time series plot. Okay, how do I draw a trend line? How do I draw a trend line? Now trend line just means trend line, I want to make this clear, trend line is the same thing as regression line. So you want to physically draw the regression line on the same time series plot. Now to draw a line, and I want to emphasize this, you need 2 points. Okay. One of the points you can easily get, it's just the intercept, the y-intercept, okay, or the axis intercepts. So we know the intercept's 12.5. I'm going to draw, I'll try to do this in a different color, maybe black. So 2, 4, 6, so 12.5 is here, and I need a second point, okay, because I need 2 points to draw a line. So how do I get a second point? Maybe if I calculated, so we've got an equation or regression line, we need to calculate another point on that regression line, so, or our trend line. So what I can do is, let's calculate what our value is at 11. Okay, how do I calculate the value at 11? So I literally plug in the equation at 11. So I'll go clear all. 12.5 minus 0.258 times 11. We're predicting what the sales percentage is at year 11, okay, based on our regression line. So it's 9.662. Okay, so 9.662. So at year 11, sales percentage is 12.5 minus 0.258 times 11. So we're predicting at 11 we get 12.662. Okay, perfect. So at year 11, so we go year 11, we're at 12.662. So 12.662. No, 9.662, sorry. I was wondering. 9.662. 9.662, so 2, 4, 6. 9.662, that's 2, 4, 6, 8. So 662 is around here. Okay. So all I need to do, and this is going to be It's not going to be as nice as the one you're going to do because you have a ruler, but what you need to do is you need to draw a line that goes to these 2 points. So I'm going to physically draw a line that goes through these 2 points, and that's your regression line. Okay, so basically I've drawn a regression line that goes through those 2 points, and that's basically how you do a regression like that. So using the trend line, forecast the percentage of retail sales which are made by the stores in year 15. Okay, can you see that the data only extends to 12.3? So this is known as extrapolation. You're going beyond the data values. You're predicting beyond the data values. So to predict at year 15, you're just going to go 12.5 minus 0.258 times 15. So it's 8.63%. Okay, so for part E, you're just simply subbing in 15. So you should get 8.63%. So 8.63%. It doesn't tell you the amount of decimal places. I'm assuming it's 1 decimal place because our original data is 1 decimal place, so it's 8.6%. Okay. Hopefully that helps you. Like, it gives you an idea of like how to actually approach the question. I think the really new thing is how to actually draw a regression line. You need 2 points. Your first point will always be your axis-intercept. A second point, you can choose any value, sub it in to see like where it's meant to land. Okay, that's how you approach it.